Hi viewers, welcome to this YouTube session. See myself, Seetha, working as Assistant Professor, Department of Information Technology. So now I am going to discuss about hashing topic. That's first of all, what is hashing? See, hashing is any kind of or any size of block of code should converted into or transformed into fixed size. That is for hashing. So let me see. My Ajanta sir, today Ajanta sir, introduction. Important concept in hashing, and then types of hash function, components of hashing, and then what is a mapping? It's a mapping between from starting information to and then destination. Then collision resolution technique and the collision resolution technique types. Then separate chaining and open addressing of collision resolution. The last one is we can discuss about number of types of gate questions. See, definition, introduction of hashing. See, hashing is here. Hashing is used to converted into any size of block of code should converted into fixed size of block of code. It is also efficient way to store the elements in a data structure, and using this technique obtain the store data is directly store the data to data structure. So it have some two type of keys. The one is a normal element or efficient key, that is for key, and then it is converted into hash key. So it is called as key is a k and the hash key is a h of k, and then in this process is mapping the keys. This process is mapping the keys to appropriate location in a hash table. So appropriate location hash table, this hash table is used to store and retrieve the informations. So and also it is called a hashing. Then next important concept in hashing. See, it have a two important concept. The one is a hash table and the another one is a hash functions. See, what is a hash table? Like a data structure, say hash table is used to store and retrieve the information, and also it is used to map the array position by hash function. See, array positions already we know that as array is stored in the size of array. So the size of array, the beginning value is index value. That index value should stored in array size. Then insertion of a data based on key value. See, how to insert the value in the table means each and every data should stored in key based value, and then map the keys in array index. See, already I said that arrays values should stored in or mapped into array index value. So based on index value. So each and every value should take on array size. That array size should enter into the table like a index value. So based on index value 0, 1, 2, 3, 4, 5. See, if we have 5 numbers in array size means we can declare starting from index value 0, 1, 2, 3, 4. And then next, hash function. See, what is a hash function means? The function is a mathematical formulation. See, we can apply some mathematical formulation and then we get some produce some integer value. So integer value means 0, 1, 2, 3, 4 and so on, which can use to index the hash table. So that is for hash function. And then it has some properties. It have 3 properties. The first one is easy to compute, and then uniform distributions. The final is collisions. Easy to compute means each and everything should be recovered. I mean store and recover the data from integers data. So that's why it is easy to compute. Next, uniform distribution, because of each and every data should stored in a array size. So array size means array is a collection of similar data type in a array size. So array size also we can declare based on index value. So that's why it is a uniform distribution. And then finally is the collision. If you have any collision occur, so we can rectify that collisions. Next, hash function. So it is continuous on hash functions. See, already we know that what is a hash table. So hash table is used to store and retrieve the information and then mapping the data within array size. So next, hash functions it is one of the technique. It is one of the technique in the hash functions is used to map data of arbitrary size to fixed size values using hash functions. So the result is called a hash code or hash value or simply hash. See, already I said that. See, hash table is used to store and retrieve the information, and hash functions used to do mapping the data, and also any size of black is transformed or converted into fixed size of black. That is for hash functions, and also it produces some result. That result is called as hash code, hash value, and or simply some is called as hash. And then it have mainly used some keys. So what are they? So the first one is data storage and retrieval. So I already said that. So it is used to data stored and retrieve the information. So based on hash table, used in hash table, and then data comparison. So comparison between, so checking file integrity. Okay, ma'am. Then cryptography. So what is a cryptography? Means it is this cryptography converted into plain text to ciphertext. I mean original data encoded into next level data. So that is for in cryptography concept. It is used to password hashing. So we can give a number of password for step by step process. So that is for cryptography used. And then components of hashing. So here we have three components. The one is a key, and another one is a hash table, and another one is a hash function. See what is a key? Our number of elements. We take number of elements. The elements are hash key, and then hash functions. We can use hash functions. So why we can use hash function means this hash functions called as any size of block of data converted into or transformed into fixed size of block. So that's why we are used for here hash function, and then it is converted into a hash table. See what is a hash table means? Hash table, each and every data should stored in hash table and also retrieved from the hash table. So that's why used for hash table here. See we have a number of keys. That keys are we have a 4 keys. Okay, 1 2 3 4. So if we can arrange in the array size of array. So the size of array, the first initial value is index value. That index value is 0 1 2 3. So we have 4, totally we have 4 values, and then that value is, see here value is value 1, value 2, value 3, value 4. This is our original value. This value should stored in a array size of array. That size of array index value is 0 1 2 3 4. This is for components of hashing. And then we have some type of hash functions. See what are the type of hash function means? The first one is mid square, and second one is the modular divisions, third one is folding and pseudo random number generation, and then digits or character interaction, and then radix transformations. So these 6 types of components or types of hash functions that we can see. First components. The first one is mid square. So what is a mid square? We take some value, we take some element or value, we can square that value, we can square that particular value. That particular value we can find out that middle value. Okay, that is for mid square. See the mid square method is a hashing technique. It's also one of the hashing techniques. So here we can use a hashing technique where the keys are squared. Okay, when we have take one particular value, that particular value should be converted into, I mean squared into that key is squared. Next a portion, I mean that portion is middle portions or middle digits, the results of extract from the exact form of the hash address. See first of all we take some value, that value should be squared, that is for step 1, and then step 2 we take a middle digits, that is for step 2, that is also final answer. And then we take some key, that is another key as a number, after that square that key, square that number, after that middle digits extract, we can extract the middle square. So from the squared number depends on the table size or digits count. So we take a 5 digits means automatically we can take a separate value. The separate value is third value is our middle value. That middle value is our mid square value. Next example. So the example is x equal to 2453 is our example. We can square that 2453. Our answer is 6017209. So then we take a middle square value. So middle square value is 60 and 209. 60 and 209. So our middle value, so we can omit the first 2 value and the last 2 value. So here our middle value is 172. Our hash function value is 172. Next, second type, modulo divisions. See, modulo divisions, we can take a modulo of our hash key value. So that is for modulo divisions. So the modulo divisions method is one of the simplest and the most widely used hashing technique. So this modulus operators determine the hash address. So hash address it can determine. So formula hash of key equal to key modulo. Example, we have one key value, that is for hash key, h of x equal to return key divided by our table key. So we can take a 4, our h of x value is a 4, our table value is a 4, so h of x equal to 4 divided by 4, h of x equal to 0. So it is a remainder value. So we can 1 4 is 4, so remaining is a 0 and the question is a 1. So our remainder value is a hash value. This is for modulo division. And then folding method. See, here we have a two type of folding method. The one is a fold shifting method and another is a fold boundary method. So first we can see fold shifting method. So what is folding shifting method na? So it is divided into two parts. One is a partition and another is a add. After that partition we can add that value. So that is for fold shifting method. See, take an example, 1 2 3 2 0 3 2 4 1. It is for our fold shifting method value. Next we can partition. We can find out the partition. So here we can divide it into three partitions. The first 123, three numbers we can divide it into divided. So 123 plus 203 plus 241 and then we can add that value because of our condition is the first one is a partition. After that we can add that value. So automatically first of all we take some element. After that we can partition of three partition and then finally we can add our final value is 567. This is for folding method. And then folding method is second type. So what is the second type? It's fold boundary method. The fold boundary method add extra one more steps. We have two steps. One is a partition and another one is a add. So here have one more extra step. That steps are reverse boundary. So our values are reverse boundary. The first one is we can take the same value. We can take here also 123, 203, 241. So first of all we can partition that value. So we can divide into three partitions. The one is a 123, another one is a 203, next one is a 241. After that we can reverse boundary. We take a reverse boundary. So it is our partition value. We can reverse boundary means automatically we can reverse that value. So 123 is a reverse value is 321 and the 203 reverse value is 302 and then 241 reverse value is 142. Finally we can add these three values, these partition values. That partition value is 765. This is for our hash key value. So this is for our fold boundary method. And the last one is fourth one is a pseudo random number generator method. So here we take some mathematical formulation. So x of I plus 1, this x of I plus 1 equal to a of x is a more table size. So we have some table size. Already we have some hash table and a hash function. So hash table is used to store and retrieve the information and also it is converted into any size of black is converted into fixed size of black, that is for hash functions. So these two methods used here, we can take some random number. That random number called as like a list. So here we can list that list or within a square bracket, that is called as array size. So 11, 12, 13, 14, 15 the lists are. Next our hash key value. Hash key value is any value divided into any number. So we can divide, for example, the first value is hash key value is 11 by 10. Okay, 11 by 10 our remainder value is 1. Then 12 by 10 our remainder value is 2. Next 13 by 10 our remainder value is 3. 14 by 10 our values are 4. Finally 15 by 10, so our remainder value is 5. This is for hash table. This hash table used to store the based on array index value. And then fifth one is digits or character interaction method. So here also we have two methods to find out the digit or character interactions. The first one is extract the selected digits. So second one is a reverse. So first of all we can take some digits. After that we extract that particular digits and finally we can reverse the final hash key value. So we can take 123, 203, 241. This is for middle value of given number, and then we can extract the selected digits. So automatically we can extract means, so 123, 203, 241. So we extracted selected digits value in a middle means the first we have 123. So 123 is a middle value, so 2, and the last value is 241. This 241 middle value is 4. Next 203. So 203 is a middle value, so we can take a 20 or 03. So here we can take a 20. So finally we can add each and every middle value 2204. So hash key value is a 40, because of the finally we have a reverse method. That reverse method applied here after that extraction. So our reverse value is a 4022. This is for digit or character interaction method. So we can take one digits. After that we have extract that particular digits, and finally we can take a middle value and reverse that middle value. This is for our hash table value. And the last one is radix transformation method. So that is transformation method is the most important in this hash function, because of each and every data, any size of black of data should transformed into fixed size of black. Because of the why we can here use a fixed size of black means array is a fixed size. This is for homogeneous. Homogeneous means each and every data should be similar. So that's why here radix transformation method used. So first one is map the key into another key. Each and every keys should be mapped here. So first value is 4371, and second digit value is 1323, and third one is 6172, and fourth one is 4199. So first we can take the first value is 4371, and then x equal to 4371 divided by 10. So we can take a divided by 10. It's a common value, and then we have a 1. Exact value is 1, and then 1323 we have a 3, 6172 we have a x of 2, hash key of 2. So mapping key with the indices of array. See, we have some values. That value should be stored in array size. So array size is used to, based on index value we can store value. If you have a 0 values, a CD, and then AB and EDGF. So these are for index value. These are of our reference value. And then collision method. So collision resolution technique. So we have a 2 collision resolution technique here. One is a separate chain. The separate chaining is a open hashing, and then open addressing is a closed hashing. So here we have a 2 hashing. One is a open hashing, and another one is a closed hashing. So open hashing is a separate chaining, and closed hashing is a open addressing. So first we can see separate chaining. So separate chaining means we can separate the value. So we have a 6 value here: 31, 33, 77, 61, 53, 44. So most of the common numbers we can separate it. For example, if like a 31, 41, 51, 61, these are all for same 1 series value. So we can separate this 1 series value. After that come for 2, 3, 4, 5 like that. So we can separate. So our key value is key divided by 10. So h of s equal to 10. So h of s equal to hash key value. Hash key value here 10. The first one is a 0. So here there is a no 0 series value. So that's why 0 is a nil value. And then 1 series. So 1 series is a 31 and 61 is a 1 series value. So 1 series value have a 2 values. Next to 2 series, there is a no 2 series. So automatically we can put a nil in the array size. And then 3 here have a 2 values. One is a 33, another one is a 53. Then 3 equal to 2 values. 4 equal to 1 value, 44. 5 equal to nil. 6 equal to nil. 7 series have a one series, one number, that is for 77. 8 equal to nil, and 9 equal to nil. So this is for separate chaining. We can separate the based on series value. 1 series, 2 series, 3 series. So this is for separate chaining. It is a open addressing. And then open addressing. The open addressing is a closed chaining. Already we know that what is a open chaining, and then here is a closed chaining. So open addressing have a types of probing. So it is used for probing, linear probing and quadratic probing and double hashing. So it have a 3 type of probing. So what is a linear probing? Check consecutive slats. So consecutive slats means we have a number of slats. That slats should be divided into step by step. Slat 1, slat 2, slat 3, slat 4. This is for linear probing. So linearly we can split our segment segmented into the particular probing. The first we have a slat. We have a number of slat. So divided into number of steps. Slat 1, slat 2 and etc. This is for because of if there is a no slat means this is for empty slat. The empty slat is found here. Next quadratic probing. So quadratic probing check slats is increasing quadratic intervals. So we have some intervals. So linear probing is the continuously we can divide it into or we can segment it into number of slats, but quadratic probing is some quadratic intervals. We take some quadratic intervals. That intervals are slat 1, 1 square and slat 2, slat square. So we can take extra. See, it can take extra quadratic time. I mean some part of the divisions. Then double hashing. So double hashing already we know that hashing. So hashing is used to mapping the data between any size of data to fixed size of data. So here we can take extra hash functions using a second hash function to determine the step size for probing, ensuring different keys probe in different sequence. That is for double hashing. And then we can discuss about some gate questions. The first questions are a hash table used to contain 10 buckets and use a linear probing to resolve collision. The key values are integer and the hash functions used to key of 10%. Hash key is 10%. I mean modulo divisions of 10. If the value of 43, 165, 62, 123 and 142 are inserted in the table, in what location would key the value 142 be inserted? So here open chaining, I mean separate chaining. We know that in a separate chaining, that separate chaining applied to here. See, 2, 3, 4, 6. We have a number of options. See, our answer is D. See the explanations. Step by step insertion process. First one is 43. 43 divided by 10 means we can find hash values 3. The 3 is the 3 value is 43. I mean 43 is an element. The value of 43 is inserted at index 3. So we have an index value 0, 1, 2, 3. So this 43 should be located in 3 index. And then 165, again 165 divided into 10 means it's automatically 5. So 165 index in 5. So 62 divided by 10 equal to 2. This 62 located in index 2. And then 123. So 123 hash values are 3. This 3 is occupied by 3 index value, but it is not located because of already we have located in 43. So automatically collision occur here. So we can take extra index. So extra index means linear probing. Here used for linear probing moves to the next slat. But because of linear probing used to slat 1, slat 2, slat 3. So here there is a no location means automatically we can take linear probing. That linear probing is index 4. Automatically it is going to be stored in 4, which is empty because of it is a empty index in array size. So that's why this 43 replaced into 123. This 123 inserted into index 4, and then 142 divided by 10 equal to 2. See, these 2 indexes already located in the 165, so automatically it going to be linear probing the next slat. So next slat 5 also already is there in the index value, then automatically it going to be stored in 6. So then index 3 is occupied in 43, index 4 is occupied by 123, index 5 is occupied by 165, index 6 is occupied empty, index 6 is empty. So that's why this 142 inserted into index 6. This is for linear probing explanation. And then question number 2. The question number 2 is consider the following 2 statements. So first statement is a hash function is an injective functions. That is for these are often used for computing and digital signature. The first one is, and second one is encryption techniques such as DES performance a permutation on the elements of its input alphabet. Which one of the following options are valid for the above 2 statements? The first one is hash functions. Hash functions are digital signature or digital value, and then encryption techniques are converted into next step. So here both are false. Statement 1 is a true and other is a false. Statement 2 is a false and other is a true. Both are true. Our answer is statement 2 is false and other is true. Statement 2, what is the statement 2? Encryption technique such as a DES perform a permutation on the elements of the input alphabet, because here encryption technique is used to encrypt the data. If you have one data, means that data should be encrypted, I mean converted into plain text to ciphertext. So here the permutation of element of its input alphabet, that's why it is a false. See, otherwise remaining all are true. And then question number 3. So given the following input, number of digit values, and the hash function is x mod of 10, which the following of statements are true. Which following of statements true? So we can apply it for here separate chaining method. So separate chaining method we can apply means we can segregate the number of linear search value. So first one only is the x mod 10 value, and 2 only, 1 and 2 only, 3 and 4 only. See, our answer is 1 and 2. So what is a 1 and 2? 9678, 1989, 419, and as the same value, because of these all are for 9 series value. This 9 series value should be divided into mode of 10. So that's why the 2 is a correct, and then 1 and then 2, 1471, 6171 as to the same value. So it is a 1 series value. So because this also divided by mode of 10, so these two functions are true. And then question number 4. So what is an advantages of chained hash table, external hashing? That is, chained hash table is a external hashing over the open addressing scheme. See, the open addressing scheme is a separate chaining method. The separate chaining method is used to open chaining, because of each and every element should be segmented or separated by continuous value, I mean 1 series, 2 series, 3 series, 4 series. So the first options are worst case complexity of searching operations less, and second one space used to less, and deletion is easier, none of the above. Our answer is C, deletion is easier, because of here there is no open chaining, means automatically we can delete that value. So that is for our answer. And then question number 5. Suppose we are given n keys, I mean n number of keys, m has a hash table slats. So m is a hash table slats. So hash table slats means a number of slats. That means a linear search, slat 1, slat 2, slat 3. And then two simple uniform hash functions. We have a h1 and h2 is a hash function. This hash function is converted into any type of or any block of size is to fixed size of block. So further, suppose our hashing scheme has use h1 means for the odd keys and h2. H2 is a even key, h1 is a odd key and h2 is a even key, because of it is for linear search in a hash table. And then what is the expected number of keys in a slat? So expected number of slats n by m, because of first odd numbers is a h1 and even numbers is a h2. So first is a n key and m key. So n is a odd number, m is a even number. So automatically n by m is a correct answer. Thank you. We'll see you on next video.